electric fields. There are two types of charges. One is the positive charge. So we have positive and negative charge, right? And you should know by all means that objects can be charged either by friction. You should know that electric forces between the charges, and the electric forces holds the electrons in atom and then bind the atoms together in molecule. We have a positive charge here and we have a positive charge here. You should know that like charges repel, and you should also know that if we have unlike charges, they are going to attract, right? So like charges repel and the unlike charges are going to attract. This is going to go here, this is going to go here. This is something that we will use, right? हर चार्ज की अपनी एक फील्ड ऑफ फोर्स होती है, ठीक है? For example, I have a charge here which is a point charge plus q. It will have an electric field surrounding it, right? उसकी विसिनिटी में कोई भी चार्ज आएगा, for example एक positive test charge आ जाता है यहाँ पे, it will experience a force and it will get repelled. Similarly, we have a negative charge here. This negative charge is going to get attracted. You should know that an electric field can be thought of as a region of space where a charge experiences an electric force. This entire thing here is a field of force for the electric fields, right? So we are talking about field of force here. What is a field of force? It's a region of space where an object experiences a force, and if it is a charge, it experiences an electric force. In electric fields, electric charges exert forces on each other when they are separated at a distance. And the idea of electric fields, is used to explain this action at a distance, concept of field of force. Electric fields are invisible, but they can be represented using electric lines of force. How do we cater this? How do we determine that electric line of force कहाँ जा रही है? ठीक है, वो इस तरह से है कि जहां पे लेट्स से ये पॉइंट चार्ज है, पॉइंट चार्ज एक पॉइंट चार्ज होता है, ठीक है, पॉइंट, इसका अपना एक इलेक्ट्रिक फील्ड होगा. इसकी विसिनिटी में कोई अगर पॉजिटिव टेस्ट चार्ज आ जाए, जो जिस डायरेक्शन में ये पॉजिटिव टेस्ट चार्ज मूव करेगा वो डायरेक्शन ऑफ इलेक्ट्रिक लाइन ऑफ फोर्स होगा. एंड इफ this is negative point charge, so we have minus q here, and minus q is a point charge, you know that, right? And let's say that in the vicinity of this we have a positive test charge somewhere here. This positive test charge is going to move inwards, it's going to get attracted. So this is a positive test charge, and this is a point charge. Right? So you should know that the path along which the positive test charge will move is known as the line of force. ठीक है, जिस डायरेक्शन में वो मूव करेगा, that is known as the line of force, right? तो एक अगर आपके पास isolated point charge है, for example ये positive charge है, तो ये positive charge से electric lines of force बाहर की तरफ निकलती है, like this, like this, this दिस इज अ पॉजिटिव चार्ज प्लस क्यू, और यहाँ पे अगर टेस्ट चार्ज आ जाता तो दैट वुड हैव बीन मूविंग इन दिस डायरेक्शन, राइट? दिस इज एन आइसोलेटेड positive point charge. So what's happening here is that the positive discharge is repelled by a positive point charge. And the line of force is directed away from Q. The line of force is directed away from Q. I have here a negative charge, as you can see here. The line of force is inwards, 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 inwards. And why is this inwards? I told you that if we introduce a positive test charge, that is going to go in this direction. That this is an isolated negative point charge. And what's happening is the lines of force are directed inwards of minus q. It's directed inwards, right? If we have here a positive charge and a negative charge, the electric lines of force are going to go from the positive to the negative like this. अच्छा, ये निकलेंगी परपेंडिकुलर हमेशा, मतलब इसका यहाँ पे टेंजेंट होगा और ये नॉर्मल, तो ये इस तरह से देखे निकल रही है, 90 डिग्री पे वो एंटर हो रही है और 90 डिग्री पे निकल रही है। और यहाँ पे भी देखिए 90 डिग्रीज पे एंटर हो रही है और निकल रही है। देखिए अगर मैं यहाँ पे टेंजेंट बनाऊं और नॉर्मल बनाऊं तो ये 90 डिग्रीज पे, तो यहां से ये इनवर्ड्स 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 पॉजिटिव से आउटवर्ड्स, तो ये दूर से कहीं जाके ये इसके साथ इन्वर्ट हो जाता है समवेयर हियर। This is a pattern. It can be a 2-mark question. They can ask this. They usually ask this stuff. If we have here something like this, and we have a positive charge here, what's happening is that it's, coming all the way like this and like this. Precisely if this is earthed or if this is negative, all the way like this. Okay? And this is what is happening. There are certain characteristics of these electric lines of forces. Number one is line of force always leave a positive charge and end on a negative charge. Number two, lines of force always leave or end on a conducting surface at right angles. Number three, lines of force are smooth curves which never touch or cross, which means intersect each other. Number four, the strength of electric field is indicated by the closeness of the lines. The closer they are, the stronger the field, right? देखिए यहाँ पे स्ट्रेंथ ज्यादा है, इस पॉइंट पे स्ट्रेंथ ज्यादा है, ठीक है? दूर जाते जाएंगे स्ट्रेंथ वीक होती जाएगी, यहाँ पे और ज्यादा स्ट्रेंथ वीक हो रही है इधर दूर, राइट? जैसे आप लोगों को याद हो रेडियल फील्ड था, ग्रेविटेशनल पॉइंट मास का, इसी तरह से इलेक्ट्रिक फील्ड भी, अगर आपके पास एक पॉइंट चार्ज है तो उसका फील्ड रेडियल फील्ड होगा, ठीक है? उसका फील्ड जो होगा दैट विल बी रेडियल, राइट? ठीक है, रेडियल फील्ड कैसा होता है, इसके क्वेश्चन आ सकते हैं, राइट, वेरी इंपॉर्टेंट. That if we have a positive charge here, the you see that the point charge is going to exhibit electric lines of force like this. So we get a radial field, and the radial field spreads outwards in all directions. So this is an electric field around a point charge sphere is a radial field. What sort of pattern can you get for electric field around two plates? Two parallel plates but of opposite charges, and that is going to look precisely like this. So we have here this sort. So what's happening is that the electric lines of force are going to go like this. ये बिल्कुल straight parallel होंगी और ये एक uniform field आपको नजर आ रहा है. This is a uniform field that you can see here. ठीक है? So uniform field has same strength at all points. So this is the electric field between charged parallel plates with opposite signs. मुझे बताएं, what sort of configuration are you going to get if you have something like this? You have a plate like this, and you have another plate which is like this. So this is a positive plate, this is a negative plate. Electric lines of force कैसे जाएंगी यहाँ पे? ये यहाँ से निकलेंगी और यहाँ पे एंटर होंगी, और जो पास पास हैं वो क्लोजर होंगी, राइट, और फिर आहिस्ता आहिस्ता दूर होती जाएंगी, राइट. ठीक है, दे आर becoming far away like this. इसको मैं यहाँ ड्रॉ करूँ. This is somewhere here, right? So you get a pattern of this sort. So these plates are not parallel. These charged plates are not parallel.